Hi guys. Okay, so in this video, we are going to cover the exercise problems in chapter 3 from the Libre text chemistry book, the introductory chemistry book by Tro. Okay, so here we see in this chapter, we are covering chapter on matter, and the matter is anything that has mass and occupies space. So in this chapter, we will only look at the sections 3.1, 3.2, 3.3, 3.4, 3.5, and 3.6. The other ones we will cover later. So we are going to discuss the problems that relate to, basically the three states of matter, the solid, liquid, and gas. So as we know, matter is anything that has mass and occupies space. The three states of matter are solids, which have a definite shape and a definite volume. Liquids take the shape of the container and have a definite volume, but gases have an indefinite volume and they take the shape of the container as well. Now, the particles in the gases are very far away, and there is very little attraction in these particles. Liquids, the particles have some attraction, but the particles are mobile. And the gases, and a solid, the particles have a very fixed, arrangement, and a very definite and a fixed arrangement, and the particles are very close to each other. So which is what gives them a very rigid shape. Now, let's look at this exercise problem. If there is one. So exercise problem 3.3.1. Okay, what state or the states of matter does each statement describe? So you should be able to read and make sense of, what is the question asking. So basically, this state has individual particles in a fixed position with regards to each other. Fixed position means like the particles are not mobile. So it has to be, that state has to be solid. Okay. This state has individual particles far apart from each other, far apart from each other, and is far apart in space. So far apart is out of the three states, as we discussed, the far apart is the very far apart is in the gas. Liquids also, they are far apart, but not too much. They're still attracted to each other. But in gases, the attraction in the particle is the minimum. So here, the answer is gases. Then which state has a definite shape? So it's always a definite shape is of the solids. So this is something that you need to understand, the solid, liquids, and gases and their, general qualities. Next is about the matter being a pure substance and a mixture. Pure substances, as the name says, means that they are not impure, means that's not a mixture, means there are nothing else added to them, which means the same composition throughout. Okay, so this the composition is constant, and it's only one type of particles. So one type of particles could be atoms, could be molecules. Atoms are, elements make up the atoms, or in other words, the atoms make up the element. I'm sorry. So the smallest particle of an element is an atom. This means that this is made up of only one type of particles, one type which have the same physical and the chemical properties. So iron. So elements are made up of atoms. The smallest particle of an element is atom. Every element has a very specific identity, the mass number and the atomic number. And the atomic number defines the identity of the atoms. And that is what gives them the physical and the chemical properties. So this is the element. Compound, on the other hand, is a mixture, is actually, not mixture, sorry, I take that back. But when elements chemically combine in a very definite ratio, then they produce a compound. So this compound, for example, table salt is given to you. It contains 1 atom of sodium and 1 atom of chlorine. So that 1-to-1 ratio, that needs to be there in order to give this particular quality, the characteristic to sodium chloride, which is a compound. So the characteristic here is solid, white colored, salty taste, very high boiling point, very high melting point. You see that? So soluble in water. So all these are the properties of table salt. Now, table salt, every single, whether you pick it up from here, anywhere you pick up, it is still going to be the same, same properties. That won't change. Okay, next is the mixture. Now, mixtures, as the name says, is impure. Impure means like mixture of 2 or more substances. Excuse me. If these two substances look the same, look the same, then it's the homogeneous mixture. But if two or more substances look different, like you can identify the individual components, then it is a heterogeneous mixture. So the way I remember this T, and two or more. So that's why you can see two or more substances in a heterogeneous mixture. Example, salad dressing. Salad dressing, you can look at, the things that are made in a salad dressing or even in a salad, So you can see the components, individual components can be seen by the naked eye. But in homogeneous mixture, they are the same. For example, here's the apple juice. So you take water and you add some apple juice to it, it all looks the same. If you take water and you add sugar to it, the sugar vanishes, but the water tastes, sweet. So that's the homogeneous mixture. So homogeneous mixture looks the one, it's the same. Okay. Now there's always this term we use, substance. Substance is a general term. Anything can be a substance. Substance can be element, substance can be a compound, substance could be a homogeneous mixture, can be a heterogeneous mixture, doesn't matter. Right? So these substances is a very general term. Now let's look at the exercise problem 3.4.1. Here, identify each substance as a compound, an element, a heterogeneous mixture, and a homogeneous mixture. Now you have to think about it, and then you're going to remember how these substances look to you. So for example, a white wine. So if you have seen white wine, it all looks the same. So it is a mixture, looks like it's a mixture of, a few things, alcohol, water, and mixtures, because it's all the same. It's the homogeneous mixture. So it's kind of like a solution, but a homogeneous mixture. Okay. Next, mercury. Mercury, the one that is in the thermometer or in the barometer. So mercury is an element. And this mercury, so elements are what you see in the periodic table. That's all the information. So elements and atoms match together, molecules and compounds match together. Okay, so they make the small particle of a compound is a molecule. Small particle of an element is the atom. So element and atoms go together and they are found in the periodic table. So if you look at it, obviously, you're not going to find a dressing or a table sugar or a wine in a periodic table. You're only going to find information about the atoms of that element. And mercury is one of that element. So this is found in the periodic table. Okay, next is heterogeneous mix. So T. So that means you will be able to see the individual components. So here, ranch style salad dressing, or forget the ranch styles, salad dressing or salads, even the salads, all of them, you can see the individual components in there. So if you have not seen a ranch style salad dressing, just keep this in mind that, you can see the parts to it. So it's a heterogeneous mixture. Table sugar, if you've seen sucrose, a table sugar, it's all white little particles, all of them, it's just white particles. So it is a pure substance, but it's more of a compound. Okay, so that's the way you identify. So I want you to go back and think about certain other things you see specifically in the kitchen, whether it's a homogeneous, whether it's heterogeneous, or whether it's an element or a compound. I mean, you can see elements in the period in your kitchen also. For example, aluminum foil, right? That is an element. Or let's say you have an iron skillet, right? Iron, like the thing that's made up of iron, maybe. So that is that iron pot or a pan. That is an element. Okay, so it's not that hard. The rest, majority of the things that you guys are going to find in general are compounds. Are compounds. Now, next is how would the chemist categorize an example of matter? Coffee. What is coffee? So categorize each example of matter. So it's a homogeneous mixture. Coffee, like it depends what coffee are we looking at. Let's say it's a coffee, liquid coffee. So coffee liquid, it's all like sugar and the coffee beans and water and milk, all of them mixed together. And then we have a homogeneous mixture, okay? Hydrogen. Now, hydrogen is a gas. We can find it as a gas, hydrogen gas, but also hydrogen is also an element which is found in the periodic table. Next is an egg. An egg is a mixture, kind of a mixture of several compounds, right? Proteins and other nutrients, an egg yolk and whatnot. So that's the heterogeneous mixture. You can clearly see the individual components, even with the egg yolk and like those, what is that? you know, the sticky white stuff, all that. So that's all like a heterogeneous mixture. Okay. All right. Next is we're going to look at the physical and the chemical properties. Now, physical properties of the substances are what you can make of that by looking at the physical characteristics of it just by your, first of all, by your senses, like look, like smell, like taste, right? Like taste, hearing, you know, what kind of sounds, like when you touch it, how does it feel like? So those things, tasting, hearing, smelling, touching, seeing, all those colors, whether it's a solid, liquid, gas, what color it is, you know, those things. Next thing is the density, right? Specific gravity, specific heat of a substance, then boiling point, melting point, right? Then comes the freezing point. Like all these are physical properties, but chemical properties are the behavior, whether they're going to react or whether they are not going to react. If they're going to react, how do they react? Do they explode? Do you need to provide heat to it? Is it going to liberate heat, right? Does it need a little catalyst for the reaction to start? So all those are chemical properties. So these are the two broad categories, you know, we define. So define like the matter. So here is an exercise problem. Which of the following is a physical property of matter? Physical, like I said, is something that you look like physical characteristics like outside. So corrosiveness. Now corrosiveness is when there is a corrosion, like means when there's erosion of the surface. So like acids, when they fall on something, they erode. They can eat through the surfaces, you know, they fall on the skin, then they can cause like skin burns on the skin, like eating. So corrosiveness is that. So obviously corrosiveness is a chemical property. pH, the acidity, clearly, you know, it is the acidic nature. You're trying to determine the acidic nature. So that also is a chemical property. Flammability, whether something will catch fire, whether something will not catch fire. Not everything catches fire. So flammability is that whether something will catch fire or not. So it's definitely a chemical reaction. So all three are chemical reaction except density. Density is very simple, whether something is light or whether something is heavy, whether something will float on water or whether it will sink in water. So that's like, you know, that relates to the density. So the physical property is density. So you should be able to look at, you know, these properties and identify, you know, their physical and chemical characteristics. Okay. So next exercise problem is, which of the following is a chemical property? Now you should understand like chemical property, flammability. So catching fire is definitely a chemical reaction. So that's a chemical property. Melting point is always a physical property. Boiling point is a physical property. Density is a physical property. Because see, here's the thing with the chemical properties. That means prone to reaction, so that new substance is formed. So whenever something catches fire, obviously the original substances loses its you know, identity, and then a new substance is formed. Even if it means like everything gets decomposed, still something new is formed. So chemical properties is that. So flammability is a chemical property. Okay. Now let's look at another very interesting one, which is a physical and a chemical change. Now physical change is a temporary change. Okay, so it only changes. You can change a solid to a liquid to a gas, and a gas back to a liquid, and liquid back to a solid, or you can even convert solid to a gas, and gas can be converted to a solid. All these are just by simple change in temperature, but the inner core, the chemical composition does not change. Okay. Physical change is also like if you are mixed together, you mix certain things together, and then you can just, you know, you can basically separate those mixtures. You can separate that mixture very easily by very simple means. And those simple means could be simply by, you know, using your hands or filtering or boiling off or evaporation, those things, simple methods. Okay. Next is physical change also is like if something breaks up into the small parts, like for example, you're cutting something, cutting a ruler, cutting the paper, cutting with a scissors, cutting a paper or something, causing a dent into something, stretching something. So that's just changing the shape, but it's not really changing the chemical composition. The substance, when you cut a piece of paper, the piece of paper, one half and the other half, they still remain the same in properties. They don't change. Then making solutions is also a physical change. In other words, solutions is a type of solutions is a type of it's a mixture. So you take a salt, you put it in water, that's making a solution. You take sugar, you put it in water, making a solution. So those are just temporary changes, because you can recover the sugar and you can recover the salt from out of the solution also by simple methods. Okay, so here, chemical changes are more complex changes. A new substance is formed always. The first substance loses its own identity, and then a new substance that is formed has a totally new set of properties. Okay, and you cannot go back to the original substance. So anytime there is like temperature change, like something that is giving lots of light or heat, or the temperature goes down, extremely goes down, and something becomes very cold, so that indicates that some kind of a chemical changes occur. Whenever the reactions give off light, explode, obviously that's a chemical change. When there is an unexpected color change, some new substance is formed, when not all the time color change, but it is still like a color change can be an indicator that a chemical reaction has occurred. Whenever bubbles are formed, chemical reaction is definitely occurring, but not necessarily. Depends, it sometimes, because carbon dioxide can be bubbled into water and it can still remain like in the bubble form. But, generally, whenever two substances mix together, if they begin to froth, fume, and they give, you can see a lot of bubbling, then these vapors, and there is a smell to it. Yeah, it's a chemical change. Okay, now smell, different taste, that's a chemical change. Whenever a solid is formed, a solid is called technically a precipitate. So sometimes it's float, sometimes it sinks, so that's a chemical change. Okay, so here we see in this exercise 3.6.1, label each of the following changes as a physical and a chemical change. So a mirror is broken. So no matter how many pieces of mirror you see, in this broken form, each piece will still have a mirror in it. And you can still say like, okay, this is a part of the mirror, but nonetheless, it is a mirror. So the property did not change. It's just the size, the look changes. So this is a physical change. So even though it's going to be very difficult to go back and mend the mirror, but still, it's a temporary, it's a physical change. Okay, iron nail corroded in moisture air. Now corrosion is always, that means an iron in the air, obviously it is rusting, it is producing a new substance. So this is a chemical change. Next is a copper metal is melted. So anytime whether something is melting, whether something is freezing, whether something is, you're boiling something, vaporizing, all these are temporary changes. These are physical changes. So melting of copper is a physical change. Okay. A catalytic converter changes nitrogen dioxide to nitrogen gas and oxygen gas. Obviously, this is a chemical reaction. New substances are formed and a gas is formed. So this is a chemical change. Okay. Now separating mixtures through the physical changes. Now, simple methods, as I said, was like filtering thing, decantation, like making the substance sit, for a long time, and then slowly removing one part from the other once they settle under gravity. Boiling things off, evaporating, so you can separate like salt and water. So if water evaporates, salt is left behind. Then using hands, sifting, and one of the other more complex physical method of separation is distillation. So this is a distillation apparatus. So here are the two things. Let us say two liquids. You want to separate two liquids. How do you separate them? You use this distillation method. Fractionating column. This is a condenser, and here is this flask which receiving flask. Okay, and this condenser, you have this jacket of cold water that just spins around this condenser. So now comes, and here you have, they haven't shown it here. Here is a thermometer actually. Now you start boiling this. So when this substance boils, the one of the liquid that boils faster evaporates first. So when it evaporates, it's obviously, this is all like a closed container, closed system. So where do the vapors go? The vapors rise up. So right here, when the vapors touch the tip of the thermometer, what happens is that the temperature reading on the thermometer, it stabilizes. So when it is stabilizing, it's not moving. So that means like now the boiling has occurred. So when the boiling point, that's the boiling point, you note down the temperature will remain stable. The temperature won't move. So on the thermometer, the temperature doesn't move. And what's happening here is that the temperature, it remains stable till all of the liquid has boiled off. So the liquid with a lower boiling point, it evaporates first, converts to vapors. Now these are gaseous vapors, they go here. And when they come through the condenser, it's very cold here. Inside this container is obviously very hot, but outside here in the condenser, it's very cold. So what happens is that these liquid vapors, gaseous vapor, immediately get condensed, become a liquid, and the liquid is then collected here. The temperature reading remains stable till all of the liquid has boiled. Once all of the liquid has boiled, the reading moves up. Now you are going to slowly remove this flask and bring in a new one, empty one. Now the next liquid begins to boil. Same story happens. The vapors go up, go to the condenser. There inside the condenser, they start condensing. And right at that time, when this phenomenon is occurring, the temperature becomes stable. It does not change. Why? Because all of the liquid vapors, once they are collected and gone through the condenser and they're collected in the receiving flask, the temperature will continue to remain stable and all of the liquid begins to boil. So this way you can separate the liquids. You can separate the liquids containing many number of, liquids. So if you have 5 liquids, a mixture of 5 liquids, you can separate them by this distillation apparatus. So the here premises that the liquids boil at different temperatures and they can be then isolated using their boiling points. So that's the distillation. Okay, now this piece right here is a very simple filtration. You take this funnel and you put a filter paper, and then just pour the liquid with the solid in it, and then it just filters the solid from the liquid. The solid on the top is called a residue. The liquid that is left here in the bottom is called a filtrate. Okay, so that's the method of separation. Now, this part, conservation of mass in the new matter, we are going to stop here. We are going to only do till 3.1 till 3.6, and we're going to come back to it later. Okay. All right. Thank you. Bye-bye.